All right, congratulations on making it through your test and getting onto this enrichment level. So we're going to look at what we call equivalent ratios. They're really similar to equivalent fractions. So when we've talked about how, okay, that fraction is the same thing, it's just if we could simplify or maybe we need to make it bigger. This is the same concept here. So let's look at this first example. You should have your 3H notes open and following along. We got 3 examples and you're going to get a bunch of options to practice before trying that enrichment above and beyond assessment. So let's start with our first example. So it says the number of dogs compared to the number of cats in an apartment complex is 2 to 5. If there are 15 cats in the apartment complex, how many dogs are there? So we're going to use what we call equivalent ratios. And so the first thing I got to pick apart from this problem is what are we comparing? Well, it says dogs compared to cats. And remember, order matters, so dogs come first, then cats. Now let's make sense of the numbers related to that. So in the general ratio they give us, or what I call the original ratio, they say that it's 2 dogs, that's dogs came first, so the first number is 2, those go together, to 5 cats. Cats came second, so the second number goes with it. So the original ratio is 2 to 5, but that doesn't necessarily mean that there are only 2 dogs and 5 cats in the apartment complex. So they go on to tell us that there are 15 cats in the apartment complex. So using this original ratio, we need to figure out this missing piece of, well, how many dogs are there? So in order to start figuring that out, we're going to use that equivalent ratio, and what that means is that we're going to use our multiplication to go from our original ratio to now a bigger ratio. And in order to do that, we got to do the same thing to both sides of our ratio. So we got to think, how did we get from 5 to 15? So I'm sure you're thinking, right, how do we get from 5 to 15? Well, we times by 3. We multiply by 3, because 5 times 3 is 15. So if that's what we did on this side, then we have to do the same thing on the other side. We have to do the same thing to 2. So we have to times that by 3. And when we do, of course, you know, we get 6. So then that's our answer, is because there were 15, using this original ratio, because there were 15 cats and we multiplied by 3 here, and we had to do the same thing to keep our equivalent ratio. Remember, equivalent is like equal, so we got to do the same thing to both sides. And so we end up with 6. So then our answer is 6 dogs. That's how many dogs are in this particular apartment complex based off of this ratio and the information they gave us. Let's try another example. And this is just one way, by the way, to write your ratio. I'm going to show you that you can also do it in a fraction style. So let's look at this example. So example 2. And again, if you need to pause the video, go back, take another look, feel free to do that. It took Megan 2 hours to complete 3 pages of math homework. Assuming she works at a constant rate, if she works for 8 hours, how many pages of math homework will she complete? Man, Megan's math teacher seems pretty tough. Luckily, you don't have that tough of a math teacher. So, anywho, sorting through this information, we know that our original ratio is 2 hours, so I got 2 on top, I'm choosing the fraction way this time, compared to 3 pages of math homework that is completed. So 2 to 3, so hours compared to pages. So then they go on to tell us, well, what if she were to work 8 hours? So if we keep that related, like keep that kind of on like the same side or same row as the hours, we would have 8 on top compared with the 2. So again, just like before, using equivalent ratios, whatever we do to one number, we have to do to the other. So you got to think, how did I get from 2 to 8? So we obviously multiplied by 4 to get from 2 to 8, so that's what we have to do to 3 as well. So when we do 3 times 4, we end up with 12 pages as our answer. That's how much math homework she would have done. Wow, that is way more math homework than I'm sure you're used to. Good thing we do a lot in class. That is tough. Whew! Hope Megan can get through that math class. So that's another way you can show it, is with fractions like that. Okay? But again, using that equivalent, what are we doing with one number to get to the other? Let's look at one more example. This one's just a little trickier. So we've got Mason and Lainey. They are running laps to train for the cross-country team. The ratio of the number of laps Mason ran to the number of laps Lainey ran was 3 to 4. So Mason came first, so that 3 goes with Mason, and then Lainey came second, so the 4 goes with Lainey. Then it tells us if altogether they ran a total of 21 laps, how many laps did Lainey run? Okay, so they don't tell us the total in the original ratio, but think about it. If Mason's running 3 laps, Lainey's running 4, how many did they run all together? Because we got to know that total, because then they use that later on. So we're actually comparing this as a part to whole, a Laney compared to the total. So to get to the total from the original ratio, we're going to take the laps that Mason ran plus the laps that Laney ran to get 7. So we're going to compare Laney's laps of 4 to the total laps of 7. That's our original ratio. So we had to do a little bit of work to get this original ratio, but it's nothing we couldn't handle. So now the other piece of information they give us is in actuality, they didn't just run 7 laps, they actually ran 21 laps. And that was a total of 21 laps, so we're going to keep it on the bottom here with the total. So let's see, how did we get from 7 to 21? We multiplied by 3 in this case. So we need to do the same thing with the top number and do 4 times 3. So to know how many laps Laney ran, it would be 12. So Laney ran 12 laps. Whew, Laney got a good workout. So that's some ways you could use equivalent ratios. And again, you can write it as a fraction. You can use the word to, or you can even use the colon, just like we have with other ratios, but you're trying to figure out that missing piece. So you'll know 3 pieces. You got to find that missing one of that 4th piece. So there's a couple of IXLs that you can try, and after that, there are some task cards for you to try as well. So lots of practice before you get to that enrichment test, and I know you're going to ace it. Good luck!